Okay, so just waiting for the red bit to come around the border, just to confirm that, yes, so I think that's being recorded. Can somebody just confirm you can see that slide?
Yeah, I can.
Okay, cheers, thanks. Right, okay, so this is what you saw last time. We just practiced working out specific terms from arithmetic sequences using this little formula here. And yes, so we're going to move on to looking at slightly more problem-solving type ones of those today. Just wanted to pop this slide up. This is the current state of play with regard to the Hegartys that I've set as the homeworks. So I was just saying to Alex before we started, I'm pretty sure, and Alex thought so too, that once we get to half term, these lessons finish. So I am going to have to write a report after half term. So it would be really helpful if you guys could just try and get this up to date or pretty up to date. Doesn't mean you've got to get 100% throughout, but really this will be what I'll be looking at when I report back on how well you've been keeping up since we've been in lockdown. So, so Alex, you're fine. So the rest of you, obviously where you've got gaps, can you fill in the gaps? I think 50% is fine. This isn't easy stuff. So I think really your goal should be to get 50% or above and just fill in the gaps, please, guys. So that was bringing us up to date from where we are now. So if you just play the video back after with the recording back, you can just see which bits you've got to fill in, please. Right. Okay. So I've actually modelled all 4 types of question you're going to be getting today, because I thought these needed a little bit of work. So we are still just using the same formula. Okay. Actually, did I make it clear which one we're doing? Yeah, Hegarty 922. 92 is going to be the one you'll be doing today. So, so I just wanted to model all 4 answers. So it will just take a few minutes. So this is the first one. So an arithmetic sequence has a first term equal to 7. So obviously A is 7. Yeah, A is the first term. Now we're told that its 14th term is twice its 7th term. So you just start off by getting equations for the 7th and the 14th term. So the 7th term is obviously 7 plus 6 lots of D. Remember the difference between which term you're looking at and the number in front of the D is 1. So the 7th term is 7 plus 6D, and the 14th term is 7 plus 13D. Now this is the key bit. The 14th term is twice as big as the 7th term. So you would need to double the 7th term to make it equal to the 14th term. Okay, the 14th is twice as big. You've got to double the smaller one to make it equal to the bigger one. So that's the key line, that you realize that if I take my 7th term and I double it, that is then equal to my 14th term. So that's the key bit. You then just process the algebra. So claw, bring all your D's and all your normal numbers to one side and the other. You get D equaling 7. So I know that A is 7 and D is also 7 on this occasion. And they're just asking me to write down a formula. So just subbing that in here. So 7's going in here for A, 7's going in here for D. Multiply out the bracket, 7 times n, 7 times minus 1, and gather up the like terms. 7 take away 7 disappears. So in fact, this one just boils down to just being 7n. So that's what question 1 will look like. It will be that sort of idea. Question 2. So again, let's just work through this. So similar to question 1, we're told that the sum of its first and second terms is 12. So just remember how these work, that the first term is A, the second term would be A plus D, then A plus 2D, and so on. So we're told that the sum of the first and the second term is 12. So A plus D equals 12. So gather up your A's, 2A plus D equals 12. There's equation number 1. Let's just bank that for now. Then moving on to the second statement, the sum of the third and fifth term is 22. Well, the third term is A plus 2D. Remember the difference of 1. And the fifth term is A plus 4D. So gather up your A's, gather up your D's. You get 2A plus 6D, and they told us that they add up to 22. So there's equation number 2. Equation number 1, equation number 2, a straightforward simultaneous equation to solve. let's call this equation 1, this equation 2. Take away equation 1 from equation 2. We get 5d equaling 10. So d is 2. Substitute that back into either of the equations. I've taken this first one. So 2a plus d equals 12. And we've got d equaling 2. So we can work out that a is 5. So I know that d is 2, a is 5. Substitute that back into the formula. Simplify it. And I get 2n plus 3. Okay, so I've substituted it into the formula, done the claw, and then gathered up my 5 and the minus 2 to make it plus 3. So that's what your question number 2 is going to look like. Now, question number 3, similar idea. We're told its 8th term is 21. So a plus 7d is 21. And then we're going on about the 11th and the 2nd term. So let's just go and work out what they are first of all. So the 2nd term is a plus d. The 11th term is a plus 10d. Now we're told that the 11th term is 3 times the 2nd term. So if you take your 2nd term and times it by 3, you get your 11th term. So there's my 2nd term, multiplying it by 3, and I get my 11th term. So do the claw and tidy it up, you get 2a equaling 7d. Now what I've done here, because I know that a plus 7d equals 21, a plus 7d equals 21, I'm just going to replace this 7d with this 7d equaling 2a. All right, so that's how I'm solving this simultaneous equation, because I've got 7d in common. Okay, so I get a plus 7d, which is the same thing as a plus 2a equaling 21. So 3a equals 21, so a equals 7. So if a equals 7, then d must equal 2. And then they're asking me to work out the 100th term. So substituting into the equation, I know that n is 100, a is 7, and d is 2. Substituting in, I can work out that the 100th term is 205. So that's question 3. Now question 4 was a bit different, okay? Now, we're told here that we've got 3 terms in a row, which are x plus 4, and then 4 minus x, and then x plus 12. Now, what happens as we move from one term to the next? Well, we're adding on d each time, aren't we? We're adding d to go from the first to the second, and the second to the third. Now, just turning that round the other way, if you go and say take your second term and take away the first term, you're left with d. Similarly, if you take your third term and you take away the second term, you're left with d. So this take away this is d, and this take away this is d. So second term 4 minus x, take away first term x plus 4 equals d. Okay, second take away first equals d. And over here I've done third take away second equaling d. Okay, because d is the difference between 2 terms. So then you just work out the algebra. Be careful. We've got like a minus 1 here. Minus x minus 4. So 4 minus x minus 4 equals d. Minus 2x equals d. Okay, so equation number 1. And then over here, x plus 12 minus 4 plus x. Minusing a minus x is plusing x equals d. Gather up your x's, gather up your normal numbers, we get 2x plus 8 equaling d. Now both of these equal d. Both of these equal d, so they equal each other. So minus 2x equals 2x plus 8, because they both equal d. Work through the algebra, you get x being minus 2. X being minus 2. So let's go back to the starting point. We've just worked out that x is minus 2. So the first term is minus 2 plus 4, which is 2. Our second term is 4 minus minus 2, which is 4 plus 2, which is 6. And our third term is minus 2 plus 12, which is 10. So we can see the sequence goes 2, 6, 10. So our first term, a, is 2. Our common difference is 4. So to work out our 100th term, just go and substitute this into our formula. So 2 plus 99 lots of 4 equal 398. Right, so that's it, guys. Sorry it took so long. I just thought it was important to run through all four because they're all quite tricky and quite different to each other. So if you could give those a go, please, now that would be super. All right. Okay, cheers, guys.